This video course is intended for people who are starting out with Rhino and modeling curves in Rhino. So I'm going to start from the basic formats of just drawing curves in 2D format and then moving towards 3D massing options. I would highly recommend that you should not be afraid to hand sketch or even digitally sketch. So I use a program called GINK, 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 and that allows me to sketch on my, on my screen. And I actually use this a lot when I am trying to generate certain kind of geometries, like, certain kind of curves that really only my eye can tell. And I don't want to use it by a digital format. I want my hand to really dictate what kind of curves I want to draw. And so I would literally draw things like this on the screen. And for example, let's say you drew something by hand. Don't hesitate to draw something by hand, take a picture of it, and just put it in Rhino and trace over it. It's something that actually a lot of professionals will do. And so it's not a process that's alien to the design. I want you to pay attention to a couple of things here. First off, if you look at this curve, there is like an inflection point right here, right? This inflection point is like the transition between one curvature to another. This is very important to understand, just basic geometries. And then, we have a flat and a flat, right? And there's a certain aesthetic quality where the proportion of the height, of the proportion of the height of the curve and the transition are about the same. And it's just easy on the eye. Like your eye is going to tell before your brain can even think and process this. Your eye's already going to tell you whether something's aesthetically pleasing or not when you look at it right away. And so there's just a difference. Let me clear this and just show you a quick example. There's a difference between drawing a curve like that, right, versus a curve like this. There's just a huge difference aesthetically. There's just something very abrupt about this versus something that's more gentle and transitional with your eye. Your eye flows along the entire curve and you notice the line as a whole. Whereas in this moment here, it kind of breaks that flow of eye movement and you start to notice pieces and not the whole. I understand this is like very, maybe a little nerdy and it's probably like embellished, but this is what your eyes are telling you. And in any design curriculum, whether it's architecture or interiors, a good aspect of it is aesthetics. I mean, other aspects are the technical aspects and the narrative, which is an important aspect. But people are going to look at your design and subconsciously, they're going to have a response to it before you even say anything. And so it's so important to understand just aesthetic qualities of things. And so, that's why I highly recommend sketching things by hand, because when you sketch things by hand, there's a natural inherent quality to it that's hard to do digitally. And it's not that you can't do it digitally. You can, but it's just much faster by hand sometimes. And so let's say, for example, I have a curve, right? Let's say I drew something by hand like this, and I have a curve like this. I can go in here, and there's these two types of, if you hold down this arrow right here, there's a couple options. You have a control point curve and curve interpolate points. Control point curve will average out the curvature, whereas curve interpolate points will literally curve or bend at the locations that you click on. So for example, if I go here, I can click 1, hold shift, 2, so you probably want 3 points to keep this flat, and then my middle transition point right here, boom, and then I'll go back to the top, and then 2, like this. And so I can go, I zoomed out a little bit, and so I can go in, right, and I can modify this curve now if I wanted to follow this. So I can go in and and I'm using a gumball, by the way. I can go in and pull this curve, anyway. Like I typically like to turn my O snap sometimes when I work with curved geometries. Pull this in and try to find the geometry that you like. It doesn't have to be exact. Pull that in here. And I could take these two, or take these three actually, and pull these up like this. Let me just go ahead and get rid of the actual sketch and take a look at this. And so you have this shape here, right? We're going to come back to this shape, and I'm going to show you how we can literally create a building out of this one shape. But there's a couple of ways of producing this. One thing to keep in mind is that in Rhino, there's probably 3, 4, or 5 ways of creating the same thing, which is awesome because it shows you how flexible the program is. There isn't one way of doing something in Rhino. There's like 5 ways of doing something in Rhino, and you can pick. There's obviously going to be nuances, and there's going to be different results with what you do. And I'll show you a couple differences. So this was one way. It's a very organic way where I did curve, control point curve. I can do curve interpolate points, and it'll be the same thing, but I just want to show you the difference. You see how things start to bend right away? And so that's curve interpolate points. Sometimes this comes in handy when you have a lot of sharp curves that you want to follow. So curve, you want to go between the two and see. Typically, people will do control point curve because you can use less curves and really define the geometry that you want by using not as many points. And it's actually best to not have as many points as possible because it starts to add to your geometry. I want to show you how we can create this in a more specific manner. So let's say, for example, you don't want to do this. Let's say you want to do it by a fillet, right? So let's use some real numbers now just so we understand proportions. So I'm going to delete this, and let's just draw a line. I don't know, let's say, well, let me just turn my ortho on, 10 feet, right? Let me just go here, ZS, zoom selected, zoom out. And now let's draw a line at an angle. So maybe let's draw a line at an angle of, we start here, let's say 25 degrees. So we'll just do the greater than symbol or less than symbol, 25. And so when you type in the greater than or less than symbol and put in the degree, it'll go in those increments. So right now this is moving at 25-degree increments. So we'll go like this, and we'll also do that 10 feet, right? And we'll just copy this 10-footer right here, like this, okay? Nice. Now, we could fillet, that's an option. So if we did fillet and radius, because this is such a gentle curve, we can probably double up the radius if we wanted to. And right here, I'm going to say trim no, because I just want to see how the arc looks. So if I do radius 10, let's try radius 20. It might be too big, but we'll just see. And click here, click here. So that's pretty nice. And then let's just duplicate it here and here. There we go. So we get this curve here. So this is like an exact geometry. You know, maybe like in a professional setting, you might want to do something like this because now you're working in a very exact geometry. And if you're doing like construction documents, you could literally call out this radius, like this. You can call it the radius and the arc length actually, and show them that this is a true perfect radius of 20 feet. The same thing here. This is pretty helpful, and you can do it like this. But again, in the schematic level, you don't have to worry about that level of specificity. Just worry about the form finding. I just want to show this to you, help you understand all the options of creating the same thing in Rhino. So that's another option. So another way you can do this, let me just duplicate this here. And I use Gumball a lot, by the way. If you just hold Alt, you can duplicate things. So if you go down here, I can do arc tangent. So if I do arc and then T for tangent, right? I can, just click here, and then you can, this is more by eye. Again, it's not specific. Same thing, arc, tangent. Right there, and just click. So you're going to click. Let me do this again, just so you understand. We do arc, and then T for tangent. Click here, and then you can click a third tangent point if you want to, or just press enter with the 2, and then just click. And then same thing, arc tangent. I press spacebar to repeat my commands. Click here, enter. That's a bigger arc tangent. And you can zoom in to see where it's stopping. So this is like your actual, this is like the inflection point right here. So these are not equal, right? This is like an asymmetrical transitional point. So you see there's more emphasis on the top than the bottom, whereas the one that was the perfect mirrored one up here, let me just, you start to see you'll start to notice differences of aesthetic qualities in these types of geometries. Just join this. Okay. So again, do not hesitate to draw things and upload them on here. So you can draw things, sketch them, and then you can use the picture command. It's called picture, and you can upload an image and trace over it if you wanted to. So do not hesitate to do that. And I cannot emphasize enough the importance of sketching in any design curriculum. Do not get used to only designing on the computer. Get used to drawing things by hand. And if you want to upload it on there and trace it, please do that. So the next thing that I want to focus on are control point curves and interpolate point curves, degrees, and offsetting curves. So if we go back here and do a control point curve, let's just do a typical S curve, for example, 1, 2, 3, 4, 5, 6. So we have these control points here. And like I mentioned, you can go ahead and modify these control points as you wish. With these control points, let's say you wanted to give this a thickness. How you offset this matters. So if I do offset, and let's say that you wanted to give this a 1 foot thickness, and you notice here where it says loose, if you have loose equals no, that means that you're going to allow Rhino to create as many points as possible to maintain this kind of geometry. So you see right there. And so if I click on this curve, do you see why there's so many points here? And then if I click here on the original curve, there is, little points. And so that's what happens if you have loose equals no. If I do offset again and I do loose equals yes, it's going to maintain the geometry, maintain the points you have, but then you're going to have a loss of geometry. And so you really can't tell on here, but if I go ahead and I make, I guess, a more complex curve geometry, maybe like a little jelly bean shape, and let's use like the interpolate points here. So if I go ahead here and just do this, right? Okay, now let's go ahead and offset it with loose yes and loose no. So offset, and we'll do a loose no on the inside, right? So let's pay attention to this one. Loose equals no. It's going to maintain the geometry consistently all the way across. But these are the number of control points I have here. If I do here, look at all the control points I have here. But again, it's maintaining the consistency of the geometry wherever I go. Now let's go ahead and do offset again, but let's do loose equals yes. And go to the outside, boom. So do you see how there's a lack of consistency in the geometry? So you see right here how it gets tighter over here. Let me delete this. It gets tighter over here. You see that? Then it gets wider over here. Then it gets tighter and wider over here. So that's the big difference, but it maintains the number of control points. So that's something to really pay attention to when you do loose yes versus loose no on offsetting geometry. If it's a very simple geometry, you really don't have to worry about it, especially if it's like very sharp and not curved. But once you start going to like curved and bending geometry, make sure that you typically have loose equals no. Now, just to go back again, let me just do the curve interpolate points. I just want to call attention to what degrees can do, both in a curve and in a surface, but we'll just start with a curve. So if I go here, and you see up here it has degree equals 3. If I go in here, let me just do just so you have a good visual of what's going on. So I'm going to go in here, click here, and I'm going to change it to degree equals 1. Do you see how it gets sharp? And then degree equals 2. You see how it starts to get a little bit more curved, but still sharp. Degree equals 3. You see? Degree equals 4. Degree equals 5. Degree equals 6. So the more degrees you have on a curve or on a surface, the more gentle the transition is going to be between point to control point. And there's going to be more of a turning of a radius for each degree that you add. That's the best way that I can. The best way I can present it. Typically, I stay on just a 3-degree curve and surface, and you'll see what happens on actual surfaces. So it's just really important to understand these, I guess, settings when it comes to degrees and offsetting curves. Another very important thing to understand are tangencies. So if we go back to the circle command, there's so many ways of drawing a circle. You can draw just a regular circle, right? Another way is I can draw a 2-point circle, like if I go from here to here, That's a 2-point circle. I can draw a 3-point circle, right? So clicking from this point to this point to this point. You see, there's so many ways I can draw a circle off of tangents. The circle command is just fantastic. Now, understanding tangencies is really important if you're going to create designs that have like a gentle transition between curves or trying to connect curves. And typically you understand tangencies the best when you sketch things, right? So like, let's say you have a circle, right? You know, that's going to be a tangency, but maybe you're sketching things, you just freehand and like you have something like this and something like this, you know what I'm saying? So like there is this, right? Like this point here and this point here are two tangent points that are connected by another, arc or another circle. And so there's a lot of ways of creating this in Rhino. In my opinion, the best way of doing it is actually through circles. So for example, if I have a circle here, just a random circle, and then I have another circle here, right? And I have another circle here. I could do circle and I can do tangent and I can draw, this is my first tangent point, and this is my next tangent point. And the circle is going to go ahead and give you the tangency all the way across. So you can find it to, where you think it's more aesthetically pleasing to have this tangency. Maybe it's, like something like this, right? And then you just click and then you have it like this. Then another one. Again, T for tangent between this one and this one. Maybe it's like this. Enter. Oops, let me do that again. I think I clicked on something by accident. From here to here, like this. Enter, like that. And then let me do another one from here to here. There's another way of doing this. I have way too many snaps on, so this is why I'm getting things like this. Enter. And so then I can just go ahead and do trim and select everything if I want to, and just trim off, this and trim that off and trim this off. And then I have these tangencies, so I can trim that off and this off. And so you get a shape like this, right? And then I can go ahead and join this. Okay. Remember how I mentioned control points and how control points will start to change depending if you offset it with loose equals no or yes? That's only with curve interpolate points and control point curves, because Rhino is trying to match that curvature. But since here you're working with perfect geometry, Rhino is going to keep the same amount of points you have. So if I do offset and I do loose equals no, and let's say it's like a 1 foot wall thickness, if I go in here, do you see it's the same amount of points as this? It doesn't increase it because you're working with a perfect geometry, right? And so I mean, this is a pretty cool, like, organic space if you wanted it to be, for like a piece of architecture, for example, right? And so you can use this as a starting point for like a floor plan. And again, the nice thing is that all of these tangencies are perfect circles. So you can, if you wanted to make a diagram out of this, you could go ahead and show how everything is based off of a circle, based off like a certain module, for example. Another way of doing this is let me just do another example. I can do like a circle here, and let's do a circle, bigger one here, and then the smaller one here. I can do arc, tangent, and I can go from here to here, for example, and then you decide, from here. And then we do it again. T for tangent from here to here, like that. And then from here, oops. The reason why I like doing it from a circle instead of an arc is because, well, I'll show you why. Is because you will lose the tangency depending. You see how I lost the tangency? You will lose the tangency at points sometimes if you do arc tangent, whereas with a circle you'll never lose your tangency. Again, the same thing going here. Trim. I can just trim this off here like that, right? And so you'll get this shape right here. And then I can go ahead and join it. Now, just like how we have degrees with curves, you have, and control points in curves, you have control points with surfaces. And so if I do a plane, just a regular plane, and let me just go ahead and do a 20 foot by 20 foot plane. Let me just scale these down real fast because I want these to be something that we can work with. Okay, nice. And then let me just grab this over here. Let me scale this down a little bit more. Okay. We have this here, and let me go to perspective. Okay, if I 3 degrees and it has 2 control points. Excuse me, let me take that back. This has 2 control points at 1 degree. In parentheses, that's the current condition. Let's go ahead and keep it at 1 degree, and let's give it like 3 control points, and let's do okay. So if I go in here and I pull this control point up and pull this one down and pull this one up and pull this one up, right? Pull this one up. So if you notice, this is really sharp. Like it's just a very sharp design. And you could work with this if you want to, if this is the aesthetic you're going with. Maybe you're doing more like a faceted design, not a curved design. Let's go back in here and rebuild this, and let's change it to 2 degrees. Do you see how it just became more curved now? And let's go back and let's rebuild it. Let's do 3 degrees. Now, since I changed to 3 degrees, it's going to increase the point count. There you go. So do you understand the difference now of what happens when you start adding degrees both in curve and in surface form? Let's just go back, though, to the original. And let me just go back and rebuild this. And let's give it 4 is fine, and 3 is okay. So let's just do okay. And let's just do, I can do function F10, by the way, if I don't want to click here. Let's give this let's just manipulate this a little bit. And so let's go ahead and click on these 4 control points and these 4 control points, and let's just lift it up, like this. Nice. And so just from this operation alone, you can create so many interesting geometries and spaces and objects if you wanted to. So for example, I can go in here and I can create almost like a sine wave module. If I just mirror this like this, right? If I mirror this like this, right? And I take these 4 and I mirror them, right? Like this. And I take these and I mirror it. You start to get these really interesting shapes. And from doing this, you can, I can contour this if I wanted to, or you can start to think of this as like skylights for a building. There's so many things that you can do this. And I'm actually going to come back to this later on in another video and show you how we can start to make this spatial. But it's just interesting how you can easily manipulate one surface and turn it into a pattern. Maybe it's a tile pattern, or maybe it's a facade pattern, for example, right? We can go in here and I can go ahead and contour this if I wanted to. Maybe we'll contour it in this direction here. And then you get this just interesting contour. Maybe it's a graphic element for a poster or something. So there's so many things that you can do with this. Again, from very basic surface manipulation. Now, another element to understand is that just like I contoured right now, I contoured off a surface. If you are working on a curve design and you want to understand maybe the transition between curves and you're trying to decide which curve to select, right? So let's say, for example, let's go to top view again. And let's just go, let me just create something like this, okay? And then let me go ahead and let me just draw something like this. Let's say you want to see, okay, I want these 2 to blend it together, and I want to see what curves I get out of that. I can do something called Tween Curves, right? And it's asking me for a start and an end, and I press enter. And so I got these. Let me do it again because I got too fast. Let me do it again. Start, right? And then it'll give me a number of steps that I want, right? And so I can do, let's do 20. And then let's press enter. And so this is really helpful to see maybe, there are other curves that you're looking for, maybe not the first or the last, maybe something in between that you're looking for that you want. And so this is a great tool to use to really see what you can do, or maybe like you're creating like a surface pattern, right? Or for like a landscaping element. So Tween Curves has a lot of helpful aspects to it. Now I want to go back to surfaces, but I want to do surfaces now with the control point command. So let's me just go here, front view, and let me just do a typical S-curve again. And then let me go ahead and just copy this, like this, just over it. Let me select one of them, right? And then let me go like this, and let me pull this up, like that. Okay. And then let me go back to, so you get this shaping. This is typical S shapes. And so let me go back to, or not go back, let me pull this like this. Okay. So there's a lot of ways of connecting these, right? So one way is I can loft this between this and this. Let me do okay. So that's one method, right? Another method is I could do a sweep two. Maybe this profile and this profile are different, right? Maybe I have a profile 1, 2, 3, and then let me just go ahead and just modify this end. And same thing here. Let me just go 1, 2, 3, like that. And yikes. Let me drag this back. This is where snappy dragging is very helpful. Okay, great. So I can do sweep two. This is my rail, and then this is my rail, and these are my sweep shapes. And let me just see. Sometimes I like the geometry when I do not refit the rail, depending on the aesthetic quality I'm going for. But sometimes you want to refit the rail because you want it to average out between the surfaces. And then I can do another command here called network surface. Network surface. And then I can go into here and I can do 1, 2, 3, 4. You need at least 3 to 4 curves to do network surface and do okay. And then how you control your edge and tier curves is important because the bigger the number, the less accurate it's going to be based on the edge connection. So it's really important to understand this. So like if I made this 0.1, for example, you see if the geometry becomes less heavy, which is fine, right? Which is good, but then the accuracy, there's a loss of accuracy. So the edge curves are important for your tolerances. So 0.001 or 0.01, and it's up to you, but the geometry does get heavier and heavier. But I care more for accuracy. I just want to show you the different options you get when you go sweeps versus lofts. And then obviously you can do the exact same thing when you mirror. If you like mirrored this, right? You'll start to get interesting geometry, right? Depending how you mirror these geometries. Like if I mirror it like this, right? You'll get interesting geometry like this. And then again, I can mirror this up above each other. I do join. I could probably do rotate 3D, or if I looked at it in maybe, let me see. I think yes, it's going to be. It's an interesting shape. Let me just duplicate it here. I can mirror it like this. There you go. And you get, interesting structures like this, right? Then I can mirror it again if I wanted to, or interesting spaces. So that's what's interesting about manipulating surfaces in Rhino is that once you start to modulate it or turn it into a module, you start to get these very interesting designs. If you want it to be, you don't have to be. It can be organic and continuously organic if you want it to be. And so once you have a good grasp on what you can create with curves on Rhino, you can really start to have fun with uh, modules or spatial examples. And again, I'm going to have another video of how we can start to make things very spatial. So like, for example, like maybe you want to do like a tile exercise, right? So I could like maybe draw a circle, for example. So let me just go to top view. Let's draw a circle, maybe just something like this, right? And then let me just draw a line right down the middle like this. And a line here like this. And then let me just go ahead and just trim. Select everything and just, I always like to do dynamic trims. You don't have to if you don't want to. So trim like this, right? So we have something like this. We have this little pie shape, right? And then let me go ahead and do an arc. So let me go ahead and just do an arc command. Let me do the start. So I'll start from the middle and then go at the end. And then maybe it's something like this, okay? And then let's go to this view here. So maybe what happens with this arc is that it peels up. So if I take this point right here, and then let me peel it up like this, right? So now I have a geometry like this, and maybe it's triangulator at the end. So let me just do a P line, and let me just go from here to here to here. Okay, so now what we have is these surfaces to work with, right? Or surfaces to create. I want to create a surface here, and I want to create a surface here. There's a lot of ways of doing this again, right? So we don't need this anymore. So one way of doing this is a sweep two, where this is first rail, second rail, and this is the sweep shape. I could also do a network surface. And so it's really up to you. So let's just do a sweep two. So this is my first rail, this is my second rail, and this is my sweep shape. Enter. Oops, I think I have to explode this. Sweep two. First rail, second rail, sweep shape, enter. And that is fine. We'll do okay. And then let's do the same thing here. First rail, second rail, and then sweep shape. There you go. And so you get this beautiful shape here, you know, and there's so many things you can do with it. I could either scale it up to make it more like an architectural space if I wanted to be, or I could almost think of it as like a tile. So if I went here and just did mirror, right? You get this really interesting shape of like this tile shape, right? And I can go in here and actually let me just join it and run this. And then let me mirror it, right? That was in a perfect mirror. I could also go ahead and I could mirror it in another direction, like this, you see? And so I get like this S curve shape, right? And then I can just go ahead and start to think about how I can turn this into a pattern. You know, maybe it's like this interesting pattern that I want to play around with, and rotate it 90. You know, you start to get these interesting geometrical shapes. And I could probably give it a material if I wanted to. And then I can take, so, and then I could give it a material if I wanted to, like this. Let's just make a new layer and material example. And then let's just make it any material, to be honest. We'll just do metal. And then let me give it copper or bronze. And then do okay. And then let me just go ahead and so it's interesting how you can take very simple curves and very simple surfaces and start to turn into complex shapes, complex tiles. It's something that you really want to pay attention to, especially like a design standpoint, or even especially an architectural standpoint. I want to come back to this curved plan shape that we made here, and I want to show you a couple things that we can do to it. So one thing that we can do to is we can make it a planar surface, and we can go in here and increase the control points. So if I do function F10, currently has 4 control points. I can do rebuild, maybe give it 10 control points. Maybe a lot, or actually let's give it 9, an odd number, so there's a center. We'll keep the degrees, we'll do okay. And how do I do function F10, and then if I go right here in perspective view, you can start to push and pull certain, I can push this up, for example, and pull this up, right? And start to manipulate it as such. If I wanted to. This is an option, like an actual option, if you're doing something quick and exploratory. But obviously, you're going to start to lose the tangency points here, right? So that's a method, right? Another method we can do is I can do a bunch of spheres, and this is more so for like surface and mass and exploration. I can do some spheres from the center, so I'll do a sphere here, sphere there. Let me do another sphere, just a random one that touches all 3 like this, and then maybe another sphere like this, maybe, and then another sphere like this. Okay, we can do something like this, and then from here I can do a plane, just a really big plane, and let me put these on a different layer, just this random layer here. We have 1, 2, 3, 4, 5, 6. Okay. And then I can do split, select objects to split. Let's split these objects like this, right? Okay. We have it like that, and then we select objects. And then we go ahead and just cap it. And we do Boolean union. Right, so now these are all connected as one. And then I can take this curvature I have here, right, and just straight up. And I can do Boolean split, and I want to do this, right? And then I'm going to go ahead and I'm going to actually explode it. Well, I can go ahead and delete these pieces, but I think it's this right here. So I get these carved pieces here, right? And then I can go ahead and explode it and just create openings in here. Maybe these are like entrances, right? And then I can just go back and select objects and J for join. I think those are all the openings. I could be wrong. Let's see. You go to render view. Maybe you get like this interesting interior shape and you make it a wider 25. Right? Or maybe like this is like a column that comes down right down the center. Maybe it's like this column that comes right down and supports it, But this is just exploration. You see? It's really fun. You start working with spheres and curves. That's an option. Another option is, let me just copy that, and let me just go backwards real fast. If you want to be very specific now, if you want to like truly model this in a very specific fashion, what you could do is, let me just paste it and move this over here. What you could do is I could do a plane, right? And then this is if you want to be very specific and start to really model it the way you want in terms of like aesthetics. And again, I'm going to go ahead and split. And I'm going to split these 3. And just delete the leftover, right? And so now we have these 3, and you can really start to think of them as like curves, right? So like, let's say you have like a very specific aesthetic of how you want, like this piece to really connect, to this piece here, right? Like you really want a specific kind of connection point between here and here. And you want a really specific kind of connection point, between this space here, right? So you can do that, but it starts to become more specific. And what I'll do is, first off, I'll go in here and extract wireframe like that. And so then I get very specific wireframes here that are basically the isocurves of the surface. Let me go ahead and just hide these for now. So you see, I get these wireframes, and you can really start to think about how you want to manipulate the surfaces, right? I can go in here and like maybe I want something like this, right? That's what I want. And so now we can create almost like a shell or an orange peel, right? So I can do something like this. So we got to think of it almost like an orange peel, where I'll go like this to this quarter piece here. And maybe I want something that's like this, right? So we need to really analyze what the surface is doing here. So I could, let's see, because these are at two very different planes, right? I could do an arc tangent, and I could see what that gets us. Do you see how that's kind of going over the original? I could do it in plan view just to see. So if you go to top view, let's see, I can go, and let me turn on project for now. Go here and turn off my ortho. Let me remove control point. I don't like this one. And let me actually keep it. Let me remove control point. Let's move this one too. And let's go like this. Like that. Let's see. So right now this is not ideal, but let's just see what we're working with here. Right, and then we'll just move vertical, move it up to the intersection of this, and let me take this one and move it up to the intersection of that right there. You see? So this is what we're working with here, right? I could just move it to a near point. We move it to just to have more space to work with. Let's go back up to top view. I want to make sure I'm not messing up. So you see I'm getting closer and closer. I could technically pull this, but then it starts to come out. For some reason, I like it. I like this geometry. So let me move it back up here for now. And then take this, move it here. So I could do a gentle arc tangent here, and let's see what we get from here to here. Like, there you go. I want to make it as big as possible, so the transition, like that, you see? And then I can go in. So now I want to go ahead and just duplicate this, because you have to think of these as like shells, right? So like this here is going to be a shell, right? And then if you kept continuing doing this method, you would take this quarter and this quarter, right? And like make that a shell, right? And take that quarter and make that a shell. So it's important to understand this workflow process. Again, this is if you have like a very specific aesthetic in mind that you sketched out. So I'll go in here and select trim, right? And select everything just to make your life easier. And then I don't need this. You basically don't need any of this over here. This is as much as you do need that. Right here, let me turn this off right here. turn that and turn that off. And even here, let me do that. There you go. Okay, so now you got the shell piece here, you see? And then here, you see there's a little bump. Like I can tell where it stops. We're just around here somewhere. You see there's that and there's this. I can go in and make this, I can do arc tangent if I wanted to, from here to here if I wanted to make it as smooth as possible. If I go here, I can do arc tangent. It's so, depending on the, from here to here. And click, right? And go in here. And trim that off. So now that's very gentle, right? And so there's a couple things that we can do. I can probably do a sweep 2 on here. So if I went ahead and selected, let me just go ahead and ungroup, explode everything just so that I know I'm working with, and just take this and this. So that's, there you go. And that I already had, this is already a rail. So this is my other rail. Join this, right? And so I can do sweep 2. This is my first rail. This is my second rail. And those are my sweep shapes, right? You see? And you can get a shape like this. Again, maybe you don't like this geometry here, right? Maybe you don't like this geometry here. So you could go in and, excuse me, let me select it. And we could, let me just draw a line from here. Where's perpendicular? I'm going to snap the perpendicular, right? And then I could do, again, control point curve. And let me lock this. Do control point curve. 1, 2, 3, right? And then I could pull it in if I wanted to, any direction I want. Right? Maybe I want to like this. And so now I could sweep this or network surface this, depending on how I want. I want to split, select object to split. I want to, well, before I do that, let's do sweep 2. That's my rail right here. And I can do 1, 2, 3. Okay. So do you see the difference between this, how this is starting to curve into there versus this? But then, you know, you might get like these surface changes here. So I could also do network surface and network surface it. So that's another way, you know. So again, maybe your design is something where you are really thinking of like how you connect. You really want control how you connect these surfaces. So that's how you would go about doing it, right? You would start to think of these as little shells that you would do as network surface or as a sweep. So then you can go back in here, right? And you can put this guy back in here, you see? And then if I do hide swap, right? You don't need this quarter of the sphere anymore. You can actually get rid of it. You can get rid of this entire piece of the sphere. You don't need it anymore. The same thing here. You don't need you don't need this piece. And then depending on what you do on the inside, you're obviously never going to see the insides of the sphere. This is going to be spatial. So hopefully this is something that was helpful. If you have any comments or questions, please leave them in the comment section below, and stay tuned for more videos where I'm going to start to take this to the next level where it's going to be more architectural. Thank you.